Hello everyone, welcome to my channel. In this video, I'm gonna show you how to build a basic network that consists of 4 PCs that are in 4 separate VLANs, 2 access switches, and a router that functions as a DHCP server and also as a router to route packets between these 4 different VLANs. So first thing first, I'm gonna show you the topology that I'm going to use for this basic network setup. You can see I have 4 PCs, PCA, PCB, PCC, and PCD in 4 different VLANs, VLAN 10, 20, 30, and 40. They are connected to these access switches, and we have a trunk link between the access switches and the router, which is used for routing packets between these VLANs and also as a DHCP server. So the first thing that we have to decide when planning the network is the IP schema. Which block of IP addresses we are using, or are we gonna use the subnetting, or are we gonna use the classful networks? So if you look at this table that I have put the IP addresses, so I have created sub-interfaces for these VLANs. On gigabit 00 and gigabit 01, I have created 4 sub-interfaces, .10, .20, .30, .40 for VLAN 10, 20, 30, and 40, and I've assigned these IP addresses. How I came up with these IP addresses, I'm going to explain it shortly because I'm using this subnet mask 255.255.255.192, which is not a classful network. I'm using the subnetting to actually distribute IP addresses between these devices, networking, and the PCs. So I'm going to show you how I came up with these IP addresses. As you can see, the block of IP address that I'm going to use is 172.17.1.0 with this subnet mask 255.255.192, which is it is not a classful network, it's a classless, and I'm using the subnetting. So instead of a /24, it's a /26, means I'm borrowing 2 bits from the network to the host part. So according to this, I can have 62, 2 with the power of 6. So these zeros represent the host portion and 1 the network portion. So 6 bits for the host, so it means 2 with the power of 2 minus 2, 62 hosts, and I have 2 bits for the network, which is 2 with the power of 2 for networks. And my network IDs are like below. Here, 172.17.1.0, the first network. The next one is 1.1.64.1.128, and in each network, which I created 4 networks, I can have 62 usable IP addresses or usable hosts that I can assign to devices. So from 1 to 62, the broadcast.63, the next network starts from 65. That's why if you look at this for VLAN 10, I've put the default gateway. If you look at here, 00.10, the first usable IP address I've assigned to 00.subinterface 00.10. The next one, which is VLAN 20, if you look here, I have assigned 1.65. For VLAN 30, 129 and 193. So I can assign the rest of the IPs to the clients. That's how I came up with these IP addresses assigned to these interfaces. Okay, so I'm gonna build the topology, and then the goal actually is to have the intra-VLAN routing between these PCs. We are gonna configure the DHCP server so they will obtain the IP address automatically from this server. Then we're gonna look at the ARP cache, and also we're gonna look at the IP DHCP bindings on this router. So the environment, the simulator that I'm using is EVE-NG. Of course, you can use a packet tracer. It is the same, but EVE-NG actually we use the real ISO files, the ISO images for the routers and switches, which is a bit better than packet tracer. So I'm gonna build the topology based on the diagram, the network diagram, network topology that I have here in EVE-NG. So I'm gonna add the nodes. So first thing, I'm gonna add the Cisco router, iOS router. I'm not gonna change any specifications for the router except the name. So I put the name router here, save it. Then I'm gonna add two switches. We have switch 1 and switch 2. Again, VIOS switch. Just I rename it to switch 1. I'm gonna add another switch. Name it switch 2. Okay, then I'm gonna add 4 PCs. In Packet Tracer, there are simulated PCs. There are no operating system on the PCs, but here in EVE-NG, my PCs also have the operating system, and I can connect to them. Just I'll change the name to PC VLAN 10 because when I connect to them, I will know which PC or which VLAN I'm connected to. I have to add 4 Windows servers, and they are Windows servers, so I call it PC VLAN 20. I have to add 2 more Windows server. I call it PC VLAN 30, and I'll add another one, PC VLAN 40. Okay, the next thing I need to do, I have to connect them to the interfaces. So here, if you look at the topology, I have G00 connected to 01, 01 on the switches. So I'll do the same here. So 00 to 01 on the switch. And the next interface is 01 connected to 01 again on the switch. Actually, if we look at the diagram here, there are some interfaces that we may not have on the switch, interface numbers. So it doesn't matter which interface you connect to the clients, but just we have to be careful when we connect, for example, PCA, it should be in VLAN 10 and VLAN 20. But the numbers, the interface numbers is not important. So I'm just gonna connect them to any interfaces of the switch. For example, this one I'll connect, let's say 02, and this one for VLAN 20 I connect 03. I will do the same for this switch, 02 to VLAN 30, and this one to VLAN 40, 03 to VLAN 40. So I have built the physical topology. Everything is now connected, and now let's go to the configuration, how we're gonna do the configuration. So I have to turn on the devices. So I'm not gonna turn on the PCs now. After I finish the configuration, I will connect to, I will turn on these servers, these clients, and I will check the connectivity. So I'm using the CRT. Actually, I'm connecting to the console. In the packet tracer, you can actually use a laptop with a console connection to the router, or if you just click on the routers and switches in the packet tracer, you can connect with console. So I'm connected to switch 1, switch 2, and the router. So I have to wait until my devices are up. Just because I want to show you which part we are configuring. So keep it like this. So I have to wait for my devices to boot up. So again, as I mentioned, you have to plan on your IP addresses. This is very important. Before designing and before implementing the network, you have to plan on these range of IP addresses and which IP addresses you are going to configure on the routers or switches. Okay, so first of all, I'm gonna change the host name to SW1. Okay, so in this switch, first I'm gonna configure the links, the IP address on the links going to the PCs. So int gig02, it is going to VLAN 10. So switch port mode access, switch port access VLAN 10. And you can see because I didn't create VLAN 10 first, now it is creating VLAN 10 for me. Okay, I will do the same for 03. I go to interface 03, switch port mode access, switch port access VLAN 20. And there is a link going to the router, so I have to make this as a trunk port. So I go to 01, switch port encapsulation, trunk encapsulation .1q and switch port mode trunk. Okay, show IP interface brief. I can see my interfaces are up. Just save the config. Now I go to the second switch. So the second switch, I will do the same. First, I'll change the host name to switch 2. Then I go to int gigabit 02. So 02 is going to VLAN 30. So I have to put switch mode access, switch port access VLAN 30. I will do the same for gigabit 3, switch port mode access, switch port access VLAN 40. And the trunk link, which is gigabit 01, switch port trunk encapsulation .1q and switch port mode trunk. Show IP interface brief, and I can see my interfaces are up, and I just save the config. Cool. Now that I'm going to configure my router. So for the router, again, it's asking me to do the initial configuration. I say no, because I want to configure it myself. Okay, so the first thing I'll do on the router, I'll change the host name to R1, for example. Then I have to create the sub-interfaces and the IPs. So these are important. That's why I just put it here, because I have to assign the correct IP address to each interface, sub-interface. So I go to int gig 0.10, which is for VLAN 10. I have to change the encapsulation to .1q10 for VLAN 10. Then I put the IP address 172.17.1.1 1.255.255.255 dot, it is 192. It is not 25, it is not 0, it is 192 because I'm doing the subnetting. Let me just get a little bit smaller. So yeah, okay, I can see now. Okay, then I will do for VLAN 20, so 0 VLAN 20 encapsulation .1Q20, and the IP address I have to put 165, which is for here, for VLAN gigabit 0020. And the reason why I put 10 and 20 on gigabit 00 is because those two PCs in VLAN 10 and 20 are connected to this interface. If you look at the topology, you can see that VLAN 10, 20, that's why I have created subinterfaces for VLAN 10, 20 on this interface and VLAN 30, 40 on the other one. Okay, so now I'll go to 01. So 01.30 interface encapsulation .1Q30, and the IP address is 129, the same opnet mask, and I have to do for 40, and the IP address encapsulation .1Q40, and the IP address 193. So the first IP address in each range I assigned to the subinterfaces, and they are actually the default gateways of VLANs. So I have to also go to the main interfaces and no shut the interface. Show IP interface brief, and I can see that my interfaces are up and assigned 0, 10, 20. Now I have to configure the DHCP server because I want my PCs to get IPs in these ranges 172.17.1.1 until 62. So I'm gonna configure the DHCP server. So how I configure the DHCP, I have to create a pool, IP DHCP pool. I name it subnet VLAN 10. So I have to give which network I'm gonna use is 172.17.1.0, 255, 255, 255. You know that range. The first network is 172.17.1.0. I have to specify the default gateway. We call it default router or the default gateway for the VLANs. Which IP? The IP that I assigned to this subinterface. So default router 172.17.1.1. This is for VLAN 10. I have to create the same for VLAN 20, IP DHCP pool VLAN 20. The network that I use is 164. And what is a default router is 172.17.1.65. So I have to create the same for VLAN 30. The network is 172.17.1.128. Sorry, I forgot. No, the subnet mask. No network 172. And also for 65, I forgot the subnet mask. Oh no, I didn't forget the subnet mask. That's okay. So 17.1.128. So 255.255.255.192. and the default router 172.17.1.129. You know, 129 is for this interface, is a default gateway. And lastly, I will create for VLAN 40, and the network is 172.17.1 dot 192.255.255.255.255.192. Sorry. Okay, and the default router is 172.17.1.193. Okay. The other thing I need to do for DHCP server, because I have assigned the first IP in these networks to the default router, I have to exclude them from the DHCP pool, because now DHCP pool, when it has this network, it will assign the IP from 1 to 190 to 191. So sorry, from 1 to 62. 62 is the broadcast. So I have to exclude the IPs that I've assigned to these subinterfaces. How I will do that? I'll go and IP DHCP exclude address 172.17.1.1. Then I have to exclude 1.65. I have exclude 129, and I have to exclude 193. So these IP addresses I excluded. Okay, show run section DHCP. So to check the DHCP configuration, as you can see, these are the IP addresses I've excluded, and these are my DHCP configs. And show IP interface brief, all my interfaces are up. Okay, perfect. Now I save the config. Now it's time to verify to see if my PCs are able to get IPs from the DHCP server and they can communicate with each other. So I'm gonna just start the PCs, and then I'm gonna RDP because they are actual Windows servers. I have to make sure that the network card is set on. So let's check first VLAN 10 and VLAN 20. I put them side by side so I can check both. And then I will also check VLAN 30 and 40. And from each system, I should be able to ping other PCs. For example, VLAN 10, I should be able to ping VLAN 20, VLAN 30, and vice versa. So VLAN 20, PC in VLAN 20 is up. Log in. VLAN 10 is up. Okay, as you can see, I think it got the IP address, but we have to verify. So if I go to the network card, so as you can see, this PC is booting up. So I'll go to Ethernet. So VLAN 10, it should get the IP in this, if I go in this range. it should get the IP in this range. In this range actually for VLAN 10. Now let's verify. So as you can see, 172.17.1.2. So 1.1 is the default gateway and 1.2 is the first IP, and this is the subnet mask. So if I go also here, I can see that I have put the IP in DHCP. So it is on DHCP. I didn't put any IP manually. Let's check VLAN 20. Okay, so if I go here, yeah, I can see the IP that I received for VLAN 10 and it's working fine. Okay, let's check if I'm getting the same IP, not the same actually, in VLAN 20. So VLAN 20, it should start from 65. Okay, so I'm gonna check. Change adapter option. I'm gonna check the IP address. And the same should be true for VLAN 30 and 40 that I will check shortly. So I go here and look at the IP address, and there you go, 66. So the first IP in the range. Now something, let's check if I have connectivity, and something also I need to do before I test the connectivity between these PCs is because they are a Windows Server operating system and the firewall is on by default, I have to turn off the firewall, otherwise I will not be able to ping this between these PCs. So I'm gonna go to the control panel and I will turn off the firewall. Yeah, so the firewall is on, so I turn it off. This is for VLAN 20. For VLAN 10, I have to do the same. Let me just close this one. I'll go to the control panel. I will go to okay, Windows Defender Firewall. Then I have to turn off the firewall. Turn off the firewall. Okay. Or we can allow actually ping through the firewall. That's I think the better way, but now I go to the command prompt. Okay, now also I'm going to the command prompt on this VLAN 20. Okay, so on VLAN, for example, 20 IP config, this is the IP config on VLAN 10. Now from this PC, which is in a different actually VLAN, which is VLAN 20, I should be able to ping VLAN 10 1.2. And as you can see, I can ping from this PC. I should be able to 17.1.66. As you can see, I can ping. I also can ping the default gateway of the system. So this one, default gateway is 11. I can ping. This one, the default gateway is 65. I can ping. Now let's go and check VLAN 30 and VLAN 40. So this one is in VLAN 30. I'm just gonna log in. Okay, let's try VLAN 40. Okay, VLAN 40 is now booting up. I'm not sure why VLAN 30 is not responding. Probably there was the issue. Usually in these situations, I'll just turn it off and turn it back on. Okay, so VLAN 30, you can see immediately it got the IP address, but I'm gonna check. So in the meantime, I'll just start VLAN 30. So VLAN 10 and 20 we checked, everything was fine. Now VLAN 40, as you can see, this is for VLAN 40, PC VLAN 40. So which range? It should get the range from 193 to 254. Let's see which IP it got. Yeah, 194, which is the first IP in this range, and the gateway is 193. Okay, so first of all, again, I'm gonna I have to go to control panel, and I have to turn off the firewall. So if I want to check the connectivity between VLAN 30 and 40, so I should be able to see. Okay, so I'm going to Windows Defender. Turn off the firewall. Yeah, turn off, turn off. Okay. Okay. And then I will start the command prompt. So I'm gonna also log into VLAN 30. Okay. VLAN 40. Okay, this is VLAN actually 30, just put it up. VLAN 40, I wanted to connect to the actually CMD. So let me just close everything. and I'm gonna open the CMD command prompt because I want to check the connectivity between this one and yeah. So VLAN 30 also is up now. So VLAN 40, I should be able to ping VLAN 1, right? So VLAN 1, let's ping between VLAN 10 and VLAN 40. So if I ping 172.17.1, this one is 1.2. So you can see that VLAN 40 is able to ping VLAN 10. So if I go IP config, so from VLAN 10, if I ping 172.17.1.194, so you can see that from VLAN 10 also I can ping VLAN 40. So let's check VLAN 30 as well, and the last machine to verify. Change adapter options. Oh, I think I closed it. So, okay, so let's go and see. Yeah, so in this PC also is getting a range from 130, which is this range, 130, VLAN 30. So again, I turn off the firewall, and from this PC also I should be able to ping other VLANs that I'm gonna just verify, see if I can ping VLAN 40 or VLAN 10. So I'm gonna just turn off the firewall, and there you go. So I'll just close all other windows, and from here I go CMD. Let's check VLAN 40. Let's see if I can ping VLAN 40, which is 194. Okay, so I'll just IP config. Okay, this is 130. So if I ping 172.17.1.194, you can see that I can ping. And from VLAN also, I should be able to ping, for example, .1.2, which is VLAN 10. So we just verified that from any VLAN to VLAN communication, we can establish, and actually all PCs got the IP address. Uh, so VLAN 10, VLAN 20, VLAN 30, and VLAN 40. All PCs got the IP addresses from the pool. Now I want to verify two more things on the router. One is the ARP cache. As you know, when systems come up for the first time, they ARP for the default gateway. When they want to send a packet to another system, they ARP for because that IP is not in their network, they ARP for the default gateway. And so we should be able to see on the router, if I go to the router and issue this command, show ARP, so you can see that, for example, 1112 is the system which is in VLAN 10, and this is their MAC address, and this is the ARP cache that it shows that this system was sending the ARP message and asking for the IP address of the gateway. That is what we can see here. So you can see 66, 130. These are actually the clients which is sending the ARP message, and this is the ARP cache. when they send the ARP, it will go to the ARP cache of the router. Also, this is a DHCP server, so if I issue IP DHCP, show IP DHCP binding, show IP DHCP bindings, you can see the IP addresses that have been assigned to the clients that are distributed from, and this is the type automatic, from this router 266 to VLAN, so the PC in VLAN 10. So if I have more PCs in each VLAN, I will see all of them with their MAC addresses. Actually, we can also verify the MAC address. If I go, for example, to the system which is in VLAN 10, this is VLAN 10, and if I go to the network card, change adapter options, and if I look at so here you can see the same MAC address is here, the same MAC address as we can see here. If you compare, they are exactly the same. So the physical address of this system is also here. So it means that this IP address has been assigned to this MAC address, the physical address or the MAC address of the system. Okay, so that concludes our lab for the basic network. I hope you enjoyed this video. Thank you very much.